every glance into a small step back in time. A particular kind of exploding star always detonates with nearly the same brilliance, and that makes it a cosmic yardstick. These stars ignite only when a dead stellar core crosses a fixed mass threshold, so each blast releases a similar burst of light. Knowing the true output, astronomers read the apparent faintness to gauge enormous distances, measuring the reach of the universe at a time. A loop of rope with 12 evenly spaced knots holds a hidden right angle. Pull it into a triangle with sides of 3, 4, and 5 knots, and the corner between the short sides comes out perfectly square, every time. This is geometry you can hold and pull taut, a fixed relationship between those numbers that needs no explanation to work. Egyptian surveyors used knotted cords to lay out and remeasure fields after the Nile withdrew each year, redrawing boundaries the flood had erased. Long before the rule was written down, the rope already knew where the square corner lived. Most of the atoms in your body were forged inside stars and scattered by their deaths into clouds like the ones we drift past. Carbon, oxygen, iron, none of them existed when the universe began. They were cooked in stellar cores, then flung outward when those stars exploded or shed their outer layers. That enriched gas seeded new clouds, which collapsed into new stars and planets. You are made of recycled star, processed through generations. Every nebula is both a graveyard and a nursery, and the line between them is matter passing through. Every black hole spins, and a spinning one drags space around with it. Picture honey stirred by a spoon. The fluid near the spoon is pulled into the swirl whether it wants to or not. Near a rotating black hole, space itself is forced to rotate. Nothing can stand still there. Not even light can resist being swept along. This region, called the ergosphere, lies just outside the true point of no return. Inside it, you could still escape, but only by moving with the spin. The hole does not merely hold space, it winds it, like thread on a turning spin. You cannot tickle yourself, and the reason hides in prediction. Before you move a hand, the cerebellum sends a copy of the command forward and forecasts exactly what your skin will feel. When the touch arrives on schedule, the brain dampens it, labeling it self-made, unimportant. Tickling depends on surprise, on a touch your forecasting cannot cancel. Your own fingers are too predictable to startle you. Add a machine that delays the touch by a fraction of a second. Breaking the forecast and self-tickling can suddenly begin to work. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world, and 2 miles beneath the surface, in rock with no sunlight and no oxygen, living cells are quietly feeding. Their energy doesn't come from the sun at all. Radioactive atoms in the rock split nearby water molecules, freeing hydrogen, and the microbes burn that hydrogen for power. It's an entire food web running on the slow decay of the planet itself. The point that lingers as you pass over: sunlight is not a requirement for life. It is simply the energy source most familiar to us, and underground life found another. Seafloor can outlast a palace on land. The reason is the mud. Buried quickly in oxygen-starved sediment, wooden rope and cargo escape the bacteria and worm open water. Little oxygen means little decay, and little decay means a vessel can sit for centuries with its planks still joined and its jars still stacked. We can learn more from one sunken merchant ship than from a whole abandoned port, because the sea, by smothering it, accidentally preserved a single day frozen mid-voyage. Imagine the cable on a lift snapping and you falling with the car. You would float inside it, briefly weightless. Not because gravity switched off, but because nothing pushes back. Normally, the floor presses up on your feet, and that push is the sensation you call weight. In free fall, the floor drops away as fast as you do, so it stops pressing. You and the lift fall together, perfectly matched. Astronauts feel weightless for the same reason. They are not beyond gravity. They are endlessly falling around the Earth. Cut into a thick salt flat and you read it like tree rings. Each layer of crystal records a cycle. A wet season floods the basin, then drought evaporates the water and lays down a fresh sheet of salt, sometimes capped by a dusting of windblown mud. Stack thousands of these couplets and you have a calendar in mineral, charting how arid the climate ran over millennia. Scientists drill cores from such flats to read ancient droughts and monsoons. The driest places on Earth keep some of the most patient records of its weather. Because nothing outruns light, no warning can arrive before the event that sends it. If the sun were struck this instant, Earth would feel nothing for over 8 minutes. No flash, no tug, no hint until the light and the gravity caught up. Information itself is bound by the cosmic speed limit. This is why the universe has a kind of patience built in. Causes and their effects are separated by travel time, and the distant present stays hidden until its messengers finally reach us. Pour the right simple gases into a flask, add a spark, and amino acids appear on their own. The very building blocks proteins are made of. This was shown long ago with a glass apparatus mimicking an early sky, and it's lightning. The energy of the spark forces small molecules to bond into larger ones that chemistry naturally favors. It doesn't make life. It makes life's vocabulary unprompted from lifeless ingredients. And that's the unsettling beauty of it. The first words of biology may have been spelled out by ordinary chemistry with no one writing. Approach a black hole, and the sky behind it warps into a ring. Light from the stars directly beyond the hole cannot pass through, so it bends around the edge instead, curving along the steep slope of space. Rays that would have missed you are steered into your eye, and the hole becomes a lens, smearing the background into bright arcs. You can even see the same star twice, its light routed around opposite sides. Gravity does not block the view. It rearranges it, painting a halo of bent starlight around a circle of absolute black. You weigh slightly less at the equator than at the poles, and the planet's own spin is to blame. As Earth rotates, everything on it is flung gently outward, And that fling is strongest where the surface moves fastest, around the bulging middle. The spin steals a sliver of gravity's pull, leaving you a touch lighter near the equator. The same rotation has, over ages, swollen the planet into a slightly squashed sphere, wider at the waist than from pole to pole. Type Ia supernovae explode with such consistent brightness that astronomers use them as cosmic measuring sticks. The reason lies in their trigger. Each begins as a white dwarf that pulls matter from a companion until it nears that universal mass ceiling. Reaching the same critical point, the stars detonate with nearly the same energy every time. Because we know their true brightness, comparing it to how faint they appear reveals their distance, letting us map the scale of the universe. At his best, man is the noblest of all animals. Separated from law and justice, he is the worst. Aristotle writes this in the Politics, and the hinge is reason. The same capacity that lets us build cities and laws can, unbound, serve appetite without limit. No other creature can fall so far, because none could climb so high. What lifts us is exactly what can ruin us. The tool cuts both ways. Burrs were the inspiration for hook and loop fasteners, and the plan arrived at the design first. A burr is a seed pod covered in tiny stiff hooks. When an animal brushes past, the hooks snag fur and hold tight, and the seed rides away on a body that has no idea it is carrying anything. Kilometers later, the burr works loose and drops into fresh ground. The plant cannot walk, so it borrows legs. Each little hook is a grappling line thrown at any passing traveler. A spinning top stays upright, defying the tip-over you would expect from a still one. The secret is the spin itself. A rotating object resists any push that would change the direction of its axis. It responds sideways instead of falling over. Nudge a fast top and it merely circles, tracing a slow cone rather than toppling. This stubbornness has a name, gyroscopic stability, and it keeps bicycles steady and helps guide spacecraft. Set something turning fast enough and it builds its own invisible scaffolding. The center of our galaxy shows itself as it looked when the last ice age gripped Earth. Sagittarius A, the black hole anchoring the Milky Way, sits about 26,000 light-years away. Its glow has been crossing that gulf for 26,000 years. So we observe the galactic heart not as it is, but as it was when mammoths roamed and glaciers spread. Distance turns into deep time. To look toward the core is to peer down a long corridor of the past. The Romans had no Portland cement and no kilns fired hot enough to make it. Yet their concrete has outlasted much of ours. Their key ingredient came from a volcano. Near the Bay of Naples lies a gritty ash called pozzolana, and when mixed with lime and water, it reacts to form a tough, water-resistant binder, even underwater, where ordinary lime mortar would simply wash away. This pozzolanic reaction let them build piers in the open sea and vast domes with no steel inside to one day rust. The Earth had already manufactured the active ingredient. Divers off a Greek island once hauled up a corroded lump of bronze, and inside it hid dozens of interlocking gears. The Antikythera mechanism was a hand-cranked model of the sky. Turn its knob and pointers walk the sun and moon across a calendar, even forecasting eclipses. It worked because its gear teeth encoded real astronomical cycles in metal. The ratios chosen so the wheels turned at the speeds the heavens do. No machine of equal intricacy is known again for over 1,000 years. The knowledge to build it simply slipped out of the world and waited on the seabed. Healthy bone heals a clean break without leaving a seam, and the secret is that it doesn't patch the gap so much as grow across it. After a fracture, a clot forms, then a soft bridge of cartilage spans the break. Bone-building cells invade that bridge, replacing it with new bone and forming a bulky lump called a callus. But it doesn't stop there. Over months, the same crews that remodel all your bones whittle the callus down, dissolving excess and reshaping along the lines of stress. The healed bone becomes nearly indistinguishable from the original because the body doesn't just mend them. The moon's glow reaches you about 1¼ seconds late. That pale light left its surface, crossed roughly 250,000 miles, and only then struck your eye. So you never see the moon's present face, only its face from a heartbeat ago. The same delay let mission controllers measure the distance exactly by timing laser pulses bounced off mirrors and waiting for the echo. Light's steady pace turns every reflection into a ruler and every glance into a small step back in time. There is a hard ceiling on how heavy a white dwarf can be, roughly 1 4/10 times the mass of the sun. Push past it, and the star cannot survive. White dwarfs are held up by the pressure of densely packed electrons, but that support has a limit. Add too much mass, and the electrons are forced to move near light speed, where they can resist no further. Gravity wins, and the star either collapses or detonates as a brilliant, oddly uniform kind of supernova. A pink lake and the blue sea beside it can sit a stone's throw apart, divided by a thin strip of sand. The split comes down to salt. The lagoon is cut off enough that evaporation drives its salinity sky high. And that extreme brine is exactly what pigment-making microbes and salt-loving algae crave. They flourish and turn the water rose. The open sea next door stays diluted, normal, blue. Same sunlight, same sky. But one basin concentrated its salt and grew a garden of color, while the other simply stayed the ocean. Some stars you admire tonight may no longer exist. Light from a distant sun can take thousands of years to cross the gap to Earth. If such a star burned out a millennium ago, its final light is still in transit, still painting a point on your sky. You would go on seeing it shine faithfully until that last wave of light swept past. The star is gone, but its image lingers, a candle whose flame we still watch long after the wick is cold. Why do you yawn? One strong answer is temperature. Your brain works best in a narrow heat range, and a yawn may be a cooling maneuver. The deep inhale pulls in cooler air, and the wide stretch of your jaw increases blood flow through the face, carrying warmth away from the skull. That's part of why yawns cluster when you're drowsy or overheated. Moments when brain temperature tends to drift upward. The contagious yawn, spreading around a room, may be an old social echo, one cooling nudge rippling through a group. Some black holes fire jets of matter across distances larger than the galaxies that host them. Gas spiraling inward gets caught in twisted magnetic fields near the spinning hole, and instead of falling, Part of it is flung outward along the spin axis at nearly light speed. These beams can stretch for thousands of light years, lighting up in radio waves. It is a paradox in plain sight. The most efficient trap in the universe is also one of its great launchers. What the whole cannot swallow, it hurls back into the dark with astonishing force.